Hi there, I'm Ben Taylor. Let me talk a little bit about who I am. How many of you are familiar with HCI, or Human-Computer Interaction? There's an ACM group called Computer-Human Interaction. It's basically the same thing. It's how we interact with computers and how we design towards that interaction. So my specialty is really that HCI, but with a focus on motivating interaction. And if it makes it easier, you can call me an entertainment technologist. That's really what I prefer to be called. And I currently work at a company called Hasbro, which is the world's biggest toy company. And I invent smart toys, and I develop patented technical products that allow users to interact with data. And I'll go into more detail about that through this presentation. So it's kind of a coincidence, but I've been working in that field actually since '99. For a company called Red Octane. So Red Octane, their business model was that it was expensive to import video game hardware from Japan to America. So their business model was they'll make the hardware there in the States, and then you get the software and you can just connect the two. So they brought in these Dance Dance Revolution pads. It's like a dancing video game. And they also brought in a guitar peripheral for a Japanese game called Guitar Freaks. But nobody in the States kind of knew about this game, so they teamed up with a company called Harmonix Music Systems to make a game called Guitar Hero. And this is the Guitar Hero peripheral right here. So if you're not familiar with this game, the way it works is you have this guitar, and you feel like you're playing music by strumming it. So that's what it looks like. From that point on, I worked in R&D for a while. So I worked for Sharp Electronics in Japan. I did work for Lockheed Martin as part of their ISGS division. And I worked at this guy's startup. This guy's named Will Wright. He made a game called SimCity and Spore and things like that. Well, I left his startup, actually, to work at a company called Electronic Arts on SimCity. So this is a game where you kind of get to play out being an architect and a city planner. So you can lay out entire cities. And what was novel about this game, the game that I worked on, was that unlike previous SimCities, all of the cities were connected. So the really novel thing about it was there was a free flow of information between different cities, not just one city. So like if you polluted a lot, that pollution would carry over to the other city. And then that would cause crime to happen in that city, and then crime would come over to your city. So you had to think about yourself as sort of a regional player. It's not just the Columbo show, okay? You live in a world. After that, I was a software architect for Nexon, making mobile web game architecture. And then I started my second startup called Weaver Labs. And Weaver is a patented technology for rich media messaging that uses context in the world. So say you're out at a Starbucks, you're getting a drink, and you say, hey, I'm going to go grab a coffee. Well, you don't have to say anything else. We know that you're in the Starbucks because we have your geolocational data. We know that it's raining outside. We know that you like comic books. So it actually takes all of that data and makes rich media, makes an animated GIF, or it makes an illustration, pieces it together, and you can send that off to your friends. So this is as easy as writing something like that, or better yet, saying something like that, text-to-speech. So we actually made this for the Apple Watch so that anybody, I mean, that's not a great interface, right, to type, but anybody could compose these messages and send them off to their friends. Then I left that startup, and I joined this company here, Hasbro. And what I do for Hasbro is a traditional toy company. It's been around for decades and decades. Some products that you might know of are Transformers, Dungeons and Dragons, My Little Pony, Play-Doh, Nerf, lots and lots of stuff, Monopoly. But more specifically, what I do are smart toys. So this is a product that we released. It's actually one of the ones up for Toy of the Year right now. And the way it works is you have these cards. And in each one of these cards, there's a piece of music. So like Sia, Chandelier, just the vocal track. Or LMFAO, and you've got the bass guitar track. Well, you can lay them down on this NFC-enabled table. All of them have NFC, near-field communication, inside of the cards. And we'll use software to automatically mix that music together into entirely new, perfectly sounding songs. Never has it been easier for people to make music. That's what DropMix is. Another product that I worked on was this. So this is a Disney princess you might be familiar with. This is Belle from Beauty and the Beast. And this is a robotic Belle that dances, very high tech. And you, on your smartphone or on your tablet, you can actually teach her how to dance by dragging and dropping these different dance moves. And it actually manages to teach young girls about sequencing and the basics of coding. This one is also up for Toy of the Year right now. So, am I going to talk about toys the entire time? No, what this talk is about, of course, is the Internet of Things. And let's kind of decode that a little bit. You've got these two things, right? You've got the internet and things, all right? And when we say the internet, we're talking about that ubiquitous data store that all of us use to access our Facebook, things like that. But that's being kind of obfuscated out even further. But I think if we broke that down even further, we've got this concept of physical and digital, right? Things, the internet, the digital and the physical. And what connects that digital and physical is an interface, right? All of these things are interfaced. That's how we connect to the Internet of Things. That's what it really means, is this thing. How many people here have heard this expression, information wants to be free? Please raise your hand if you've heard this expression before. All right, well, it comes from this quote. So it was by this gentleman named Stuart Brand. He's the founder of the Whole Earth Catalog. And this was during a talk with Steve Wozniak at the first Hackers Conference in 1984. And he said, on the one hand, information wants to be expensive because it's so valuable. The right information in the right place just changes your life. On the other hand, information wants to be free because the cost of getting it out is getting lower and lower all the time. So you have these two fighting against each other. And we're going to talk more about what he's saying here about, because the cost of getting it out is getting lower and lower. Everybody here knows about Moore's Law, so we'll talk more about that. But I really want to emphasize one point of this quote, and that is the right information in the right place. What is the value of that? Well, you've got these two areas. You've got digital and physical, right? You've got the digital world and the physical world. And since 1984 and even before that, it's been this constant tug of war about where things should belong in that spectrum. So there's a vector to that. There's a vector to how the things are moving towards the digital world and how that digital information is moving out into the physical world. It's Pikachu, all right? This guy is Pikachu. And what do you have to do with Pikachu? You have to catch him. You have to catch them all. You got to catch them all. But there's a problem there. And the problem is that this guy's not real, and you guys are all real, all right? So we have to figure out a way to get this digital guy to you, the physical guy. So this is one way. We can have a handheld game. So traditionally, Pokemon has existed in this handheld format on Game Boy, on DS, things like this. And this is a very common sight nowadays with kids sitting around a couch. They're not really interacting with each other at all. They're just looking at their devices. This room is actually pretty good, but typically when I give talks like this, there's a lot of people on their phones, all right? Kind of heads down, immersed. They're diving kind of deep into that data. So, I mean, what we just saw in this image, they're on handheld devices, so it's coming out to you a little bit. So we'll see some movement of the information coming out towards the physical side, right? It's handheld. It comes with us. It's not like a gaming console or a television where I have to be there in front of it watching. But largely, what's happening is humans are moving towards that digital information because your head's down, you're not interacting with each other, you're not interacting with your world, you're still subject to gravity. But aside from that, you're not really part of that physical world at this point. But there are actually other versions of catching them all. How many of you have heard of this thing, Pokemon Go? Do you guys have Pokemon Go in Sri Lanka? No? Well, this one's a little bit different in that this uses geolocational data, and it actually superimposes the Pokemon world and all of those Pokemon on top of Colombo, on top of Sri Lanka. So this right here is the Cinnamon Grand Hotel. Right here is the Cinnamon Red Hotel right there. These Pokemon have come out into the real world. So what we see with this is a little different. That information, it's coming over more to the physical side, right? So I want you to think about what is this kind of vector of data versus users. And no matter what, they're convergent fields. We are getting closer to information and data. That's the crux of the Internet of Things. And that gap is going closer and closer with Internet of Things, mixed reality. It's a middle ground. And it's an escalating user vector. So let's talk about these two directions, okay? The escalating user vector is the vector in which the user is moving towards information. And then there's the escalating data vector. That's data moving out towards the real world, digital towards the physical. That's the second example that I gave you about Pokemon Go. So some examples of this is, we're moving deeper into technology, and that data is coming out of the real world. So you could think of that as interactive input, social media, video games. All of this is prompting you, the user, you, the real person, to digitize yourself and put it into the digital. The inverse of that is passively consumed output. This screen is an example of it. You're not putting data into this. Data is coming out, entering your retina, and going into your brain. So that's a different vector of the digital entering the physical. So you can think of print media, TV, film, etc. So how many of you know virtual reality, right? Virtual reality, you are going deeper, perfectly deeper, into a digital world, right? But then the inverse of that is augmented reality or mixed reality, where that digital information is overlaying on top of the real world and increasingly using more information from the real world. That's the distinction between AR and MR, is that mixed reality is taking in data from your surroundings. And then we can take this concept even further. Elon Musk is setting a new company called Neuralink. Have you guys heard of this? Or if you've ever read Snow Crash, right? Or these sort of things. So Snow Crash is more about VR, but these sort of things about SimStims. But the idea of a direct neural interface to a computer, the idea that I don't need to type, I don't need to use Xerox PARC mouse, I don't have to use any of these kind of novel interfaces, I can just interface directly from my brain to the digital. Maybe the inverse of that, with the information coming out of the real world, is robots. So that data, with more agency to do things in the real world, a body and sort of a corporal being for data, maybe that's robots. And then to the ultimate extent is maybe a digitized consciousness. Forget connecting to data or information. I can become information and live on the internet. Forget the Internet of Things. Let's just go to the internet, all right? Or let's take a step away from the internet and just make everything things. And that ultimate of that might be a self-aware humanoid robot where that data has been now perfectly embodied in a physical life form. That's pretty deep. Okay, let's take it back to games and make it fun. You guys know this game, Tetris, right? Classic, one of the oldest games, very, very engaging. So what could we do with Tetris, right? We're talking about interfacing with technology, Internet of Things. How could we connect this to the real world? And this, of course, is digital, right? That's what we're all familiar with. Here's a physical set for those same blocks. Well, I showed you that Weaver Labs on the Apple Watch, right? Maybe we can put Tetris on the Apple Watch. How fun do you think that would be, Tetris on the Apple Watch? No, that'd be garbage. That'd be terrible. That's a terrible interface for connecting to Tetris. Or maybe this. I can put Tetris on my shirt, and you can walk up and you can play on my chest. Does that sound fun to you guys? No, that sounds really lame. I saw this. This is pretty cool. So a dude tricked out his cabinets so that a light actually forms the different Tetris pieces, those pentaminos, and they come down, and you can actually play in your bookshelf. That's pretty cool, right? This is where I think I'd want Tetris to live, maybe. I don't know. But I think it's pretty obvious to us, because we're all developers here, that it's endless what we could do, right? But we were so preoccupied with whether or not you could do it that we didn't stop to think if you should do it. This is great Jurassic Park. Jeff Goldblum from my hometown city of Pittsburgh. This is a really funny quote. And this comes up so much in my life as a developer, in that we're so laser focused about problem solving. That's our jobs, is we think of, and we have to isolate what the problem is, and we have to figure out a way to solve that problem. But what does it mean for us as developers, putting on the design hat? How do we think about not the what we could, but what we should do? What can you guys think of as an example of that? What is the what should we do of coding? Using design patterns, right? You guys are all familiar with design patterns here, right? Not just about figuring out how to do something, but figuring out how to do it well and efficiently, right? And using the right tools for the right job. So just a quick refresher, there are behavioral patterns, like a state machine. You're all familiar with state machines, right? I have a state that I'm handling that's communicating to my digital content, and it's updating the status of my application. A state machine. And, it's the right tool for the right job. You have lots of states, you need to cycle through the states. Behavioral pattern. Structural patterns. This is an example of the adapter pattern. So you have a client interface, you have a target request, and you have to adapt that data and really kind of morph it into what you need. So you're changing the structure of that data using the adapter design pattern. There are creational patterns, like the factory method. Are you all familiar with the factory design pattern? I'm sure you use this all day long. So the idea here is that you're going to change your content. You're going to use that creator to instantiate that product and then send that product out. All of these are different tools for different jobs. And, it goes on and on what you could use. I hope you're all familiar with these design patterns. And more importantly, it's not just the intelligence of what these design patterns are, but it's the wisdom to know when to use these design patterns when you're coding. That's what separates the boys from the men. So what should we do? Use design patterns. And that kind of is going back to the right information in the right place. So let's talk about what's next. Let's go back to that kind of dreamy stuff we were talking about earlier. How many of you know who this guy is? Yeah? Go ahead, say it, please. It's Ray Kurzweil. Okay, and he wrote this book, The Singularity is Near. Let me ask you guys, how many people, raise your hand please, how many people in the room think that in your lifetime, you will be digitized human beings? We got some hands. In your lifetime, you'll be digitized human beings. I'm only seeing maybe, 6 hands in the room. Let me tell you, the singularity is here. Okay? Because we're actually, I bet everybody in this room is digitized right now. If you're born in the United States of America, you're given a social security number. And what that means is that there is no way in my country to opt out of being a digitized human being. Because there is a version of you that exists in the cloud right now. Right now. If you have this Facebook page, this guy has a Facebook page, and we know a lot about this guy, right? He went to these schools, he went to this high school, these are all his friends. This is the info that makes this human being who he is, right? There's also this. This is his professional life. This is who he is. And you take all that different data, and that's you. That is who you are. And you should be thinking about what it means to be a digital version of yourself. Because if you're saying, Ben, this version of me can't do what I can do, right? Well, what's missing? What's missing? Agency? There's things that are missing. So let's talk about virtual worlds. Okay, we talked about virtual reality earlier. Maybe this is where we're going. Deeper into technology. This is, I find, and I work in virtual reality as well, I find people are moving increasingly more into technology. And that's a little less exciting for me, but I'm not drawing the line during this talk. I'm just trying to make a point about that it being a continuous spectrum. So parents of teens, tweens and teens, these are people 19 and under. They spend more than 9 hours a day on screens. I'm sure it's a bigger number than that today. But I don't know if they're spending information on screens. This guy's using his hand, right? I think they're spending 9 hours a day in a screen, right? Because the only distinction between these two things is just it's how deep are we getting into that technology. So what's happening in this example is humans are going deeper into information. And what I really want to emphasize with this is how it's a continuous spectrum and how you take these starting points of the internet and the things, that's the starting point, and you think about the end point in which we interact with that data and what it means. What is the utility of doing that? So the utility in this instance is an emphasis on immersion, and also the result of this is a one-size-fits-all. So if you think about smartphones, if you think about all of the major VR platforms, I bet if we did a poll in this room right now and we just looked at everybody's smartphone, I think we'd only see like 4 varieties, right? So not a lot of change there. But a phone and virtual reality, maybe that's not the best for what we need. How many of you are familiar with the DARPA Robotics Challenge? You familiar with this? This actually has just been going on for, I think, maybe 5 years. It really was spurred on by the Fukushima disaster. But the way it works is, the reason why, nobody wants to make robots. They're super expensive, okay? They're really tough. It's such a huge challenge. The world is so full of data that it's really hard to interact inside of it. But the reason why we have to is because we live in a human world. All of you are sitting on chairs, and those chairs are designed for you. They're designed for the human form. That's why it's relatively comfortable for you to be sitting in it. So if we're talking about Internet of Things, and that data coming out of the real world, it's going to have to interact with things that we interact with, right? Because we live in a human world. So that data has to kind of change to match our needs. So let's talk more about that. Data's embodiment, the Internet of Everything, and the challenge of making Internet of Things products. So we all know about Moore's Law here and the price per computing. In 2025, microprocessors will be powerful enough for you to spend $1,000 and have the same computing power as the human brain. So a lot of people like Peter Diamandis and people like that, they see that number and that date as kind of when we can expect the singularity to happen. The singularity, we'll talk a bit more about that in a second. But there are a lot of big players moving into the space. So it may surprise you to see Mark Zuckerberg and that profile there earlier, but they spent $1 billion on Oculus, and they're really pushing hard into the field of virtual reality. So the biggest sponsor for this conference is Facebook, or one of the biggest sponsors is Facebook. Talk to them. Where are they going with that? Get Mark Zuckerberg on the phone. And it's increasingly easier and easier to prototype. So if any of you, I hope everybody in here, this room is interested in the Internet of Things, there's now the Intel Joule platform and Watson and everything that is available to you easily and cheap for you to get into it. You can make a very robust or anti-fragile platform for you to create your own Internet of Things product. So I would encourage you all to do that. And I'd like to also talk about the distinction between intelligence and utility. So when I think of the internet, I think of a lot of intelligence. I think of it kind of out there. And if you want to find an answer, probably what they're going to be teaching in schools pretty soon, and what's almost going to be exclusively taught in schools, is this idea of how you access information, not necessarily the availability of information. It used to be rote memorization is the way you went to school. You would go, you'd get a book, you'd assimilate as much information as you could, and then you could show that you could output that same information in some test format, right? But that's not applicable to our future. Our future is more about how we recall that information, how we access that information. So I think we're going to start talking more and more about the utility versus the intelligence that people have. They usually go hand in hand, but an anecdote that I'll give you, the now richest person in the world, Jeff Bezos, he was doing a conversation with a who is it? Susie Welch. And what he said was, Susie asked, what is it that you look at when you're hiring in managers for leadership positions? And he says, I don't care if they're smart. I don't care if they're the most intelligent person in the world. This is the founder, CEO of Amazon, right? What he cares about is them being right. He hires people into leadership because they're right. So they have a track record of doing the right thing, right? Despite how they're accessing information or what information they have access to, they just, through their interactions, have been right. And that quote, my takeaway from that is it's more about their utility than it is about their information. So let's go in the other direction for a second and talk about augmented reality. Augmented reality plays much more into the Internet of Things ecosystem. So looking at this image here, you're going through a tunnel, and maybe all of this information is overlaid over your eyesight. Maybe you're wearing digital eyewear, like these glasses here are putting data, surfacing that data to me. And maybe we can assume something like it's using a GPS to tell me where I am in this tunnel. Probably doesn't work very well in a tunnel, but it knows where I am because I've been traveling for 28 seconds through this tunnel, and it can derive that I've been going at this speed and that I'm there. Or it's using my other data, other sensors here, like an odometer and how much gas I have in my tank. It's using a depth sensor to shoot infrared light at that wall and then collect it back to know how far I am from that. Or maybe it's just using computer vision or machine learning to just get a sense of what that environment is. But the important part here is that all of that information, it's relevant to my human world, right? Because what I'm seeing here, all of this information, I didn't have to go and look at my phone while I'm driving. This is all being serviced to me, and it has perfect awareness of my environment. So it's coming out into the real world. So if we were to draw that vector, it would be like this. That information started somewhere out in the cloud. My GPS location is an arbitrary number. It doesn't mean anything but to computers. I can't say a GPS location to you as a human being, and you would be like, oh, that's Jakarta, right? But it can, and that's going to recontextualize it based on your human world. What is my proximity to Jakarta? So if you were to talk more about this and what's possible with this, this is relying on the real world and perception, and that cost is going down. The cost for sensors is going down and down and down and down. And it's great for me because I work in smart toys, and I get to make increasingly more and more high-tech toys because I can afford to sell it to you because it's cheap. It's getting cheaper and cheaper, which means my stuff is going to get cooler and cooler. And you guys can do more stuff like that. And what it also means is you can have more bespoke, custom-made experiences for you. So when I said earlier, there's probably only like 4 or 5 types of smartphone in this room. Well, Motorola is trying to get ahead of this, but the idea is that you can have more bespoke hardware for what it is that you need. Okay, so Ben, which is it? Are we going deeper into technology, or is technology coming out to us? What should it be, right? Let's pick a direction. What should accommodate what? I think it boils down to this. And it's a concept that I'm introducing at this conference, and it's the prime interfaces. So prime interfaces are optimized to optimized for contextual utility when determining where a human and information should meet. This is the answer to that slide. And it's a way of determining what that contextual utility is. What is the utility within context? What is Jeff Bezos saying when he wants customer to be right inside of the walls of Amazon? Where should they meet? Not where could they meet, because that's endless, right? We can make any Tetris game. But where should they meet based off of that contextual utility? And this goes back to this. The right information in the right place just changes your life. Just changes your life. It's valuable. So how do we determine contextual utility? We've got two things here. We've got a problem and a solution. That's something that all of us as developers can understand very well, right? And I think what that is about is, where does it exist, right? Where is that starting point for us? That's the problem, right? And where does that solution exist within that continuous spectrum of digital and physical? Human vector versus data vector. Who's moving? Is that data becoming more physical? Are we making more interfaces to come out in the world and deliver that information to us? Or are we making bespoke interfaces custom built for me to go deeper into the data? Or, it's going to be more bespoke than it is like buying a VR headset or one of 4 different VR headsets and going in deeper in that information. And by the way, this isn't just hardware as well. This is software. You'll start seeing more and more bespoke software. The idea that I can use procedural elements, or I can even talk to a voice assistant and say, I need a website in 20 minutes. I want it to have a purple background and, make it kind of look like Amazon's website. And just like that, it can generate it for you. That's the future that you guys can expect. So more bespoke software as well as hardware. And then what is the velocity to that solution? And this is really the crux of it. How does it come to you, right? What is the friction? What is the drive, the motivation, the desire for you to get to that data, right? Because that's going to talk about how fast, how frictionless we want it to come, when do we want it to come, that sort of stuff. The ease of use and the accessibility. I think this will play more into the bespoke hardware, because we're mostly built the same as human beings, but we're all different heights. Some of us are different genders. So the same tool doesn't necessarily work for all of us. And then the demographic info. And this is, what I was talking about earlier about us only having 4 or 5 different devices in this room to access that content. It's cost effective to make something that touches everybody, but it's better, and it can actually be a better way for us to interface with data, for it to be custom made for who we are. So a smaller demographic. Which humans are we talking about? And then when will I get the solution? The time element. So this talk, we've talked about this thing, the prime interface. What is the best way for information to connect to humans? And that gets down to different tools that we can use. Creational design patterns, behavioral design patterns, structural design patterns. And that breaks down to this: the what, the where, the when, the how much. How many of you are familiar with these 2 products? Do you know? Raise your hand. Do you know this product? This is Amazon Echo and Google Home, right? Why would they make these products? Why? It doesn't seem to make any sense. I mean, Amazon already has this, right? This is the same thing. This is Alexa that you can access from your phone. So why do I have to use Internet of Things to connect when I could just use my phone, which everybody has, to do it, right? Well, actually, Amazon has been innovating in the Internet of Things space for a while now. They have something called dash buttons, right? Because actually Amazon has a patent on one-click purchasing. So what you can do is you can buy these little Clorox dishwasher detergent things. You can buy cat food, your favorite drinks, and they send you in the mail a little physical button. And you can put that on your refrigerator. You can connect it to your network. And then whenever you want something, you just press a button, and it comes there to your home tomorrow. So when you think about it that way, and the fact that they've been innovating in that space and trying to connect you to purchasing faster and faster, and with as little friction as possible, it actually kind of makes sense why they would go and make something like that, right? And then Google Home. Why would Google Home have it? Did Google do it just because Amazon did it? No, I think Google has this thing. Who here knows what Google's mission is? Google's secret mission. It's secret, but most people know it, so it's not that secret. Google wants to digitize the world's information. That's their goal. All of the world's information, they want to digitize it. But they're not evil. But there's one place that they really have trouble getting to, right? They can send a car around your neighborhood. Who here has seen the Google Maps car driving around Colombo, right? It's got the weird thing on the top. It's usually on a Prius, right? That's digitizing your streets so that when some foreigner comes to your country, I can actually look around before even traveling there. Your entire world has been now digitized for my consumption as an American. But you know what? We're a private people. We want to get inside the house. So how does Google get inside your house and start digitizing your pets and stuff, right? This thing, Google Home. They're using Internet of Things to map your entire house and digitize it all. So are we forgetting anybody? Is there another player who just announced that they're entering in the voice assistant space today? Does anybody know? It's this thing. This lady, this beautiful lady here, is Cortana. This is Microsoft's voice assistant. And they just announced a couple weeks ago that they're also coming out with an Internet of Things piece of hardware dedicated to connecting to the home. Why? Why is Microsoft moving into the space now? They want to make Xboxes, kind of, right? They don't really want to make physical products. Can anybody think why they would want to do this? Well, it's got to be, right? What about Bing? We just talked about Google. You've got to access Bing. Everybody in this room uses Bing, right? Bing is the most popular search engine in this room, right? No? No. It's not. Okay. All right, you guys win. There is an existing precedent. So the idea is that, hey, if we can't sell you on Bing, we'll just give you an interface that looks a lot like what you're already using. There's an existing precedent, so there's less risk, right? But this is going to actually utilize that search that they've made. So if the interface doesn't work, if it's a marketing challenge to get you to stop using Google and use Bing instead, maybe the backgrounds Bing didn't sell you on it, well, now you can have this beautiful platform to connect to it. And heck, why not? Because making Internet of Things products like this is increasingly low cost. So it costs them a few cents to make this. They sell it to you for X amount of dollars. And now you have access to Bing, and they can continue developing the Cortana platform. But let's talk about someone who's been in the space but is on their way back. A new type of voice assistant that you've never seen before because it was just announced a few days ago. Aibo, right? This is Sony's dog. So Sony had this platform, this quadruped platform called Aibo, right? And this is a voice assistant. It doesn't look anything like Echo. They should have talked to these guys because it looks just like an Echo, right? This is what a voice assistant is, right? This is the embodiment of a voice assistant, right? Well, maybe we can do something different. Maybe Aibo can come to you. This can't do that. This can't fall over on its side and then roll off the table towards you, right? Aibo's a voice assistant that can come to you. Here, boy. Here. Come here. Right? And that's familiar. That's wonderful, right? How many of you have a dog? Right? This looks like a dog. This is something that most people are pretty familiar with. It's cute. And the cool thing about it is that it can engage you, right? If you talk about those other voice assistants, you have to engage it. You have to use a wake word and then connect to it, right? The ball's in your court. I'm just here to serve you, master, you know? But Aibo will prompt to you. So Aibo actually literally engages you. It's woof, I want to come and play. I want to tell you what you didn't know. I want to come to you and remind you the thing that you didn't even know you needed reminded. So can you see how this is still a voice assistant, but has a totally different type of utility using that same technology? So be thinking about that continuous spectrum, and don't worry so much about like buzzwords like IoT or virtual reality or being the exact opposite of IoT. It's all connected. The way you should be thinking about it is this: the prime interface. So the what, the where, the when, and the how much, that information and that human is converging and coming to that endpoint, right? So there isn't a right answer. It's not all the human-centered interface, human-computer interface show, or the computer-human interface show. Doesn't have to be a right answer. You can use different solutions for different objectives. And by doing that, you need to think of this. The what on the information side, prime morphology. So when I say prime morphology, what I'm talking about is the way data needs to exist in the right form to get to you, all right? So when I'm talking about that, it's really what is the best way for that data to be consumed by the user, right? For example, if it's the newest movie that you've been dying to see, if that movie comes to you in a language that you don't speak, it comes to you in Japanese or something, right? That's the wrong way that data is formed for your needs as a human being. So it should come to you a bit. Let's talk about the human side. What would be the equivalent of that? Prime accessibility. So the idea here is that not all human beings are built the same, right? But there are ways that we can build interfaces to get you deeper into technology and for you to better interact with that content. So for example, if you are a blind person, you can still use an ATM because it has Braille on the buttons, right? That plays into what is the prime accessibility for that human being to access the information. Prime instatement, and I'm very careful by using instatement in this term. So when I say that, this is the type of data storage that we use. This is where that information lives, right? And this is probably one of the biggest cruxes of Internet of Things, and that's security, right? We need to secure that data. We think of banking systems. We were talking about the ATM a moment ago, right? All that information, because inside of banks, there isn't like a big stack of dollar bills, right? It's all data. It's all information. And we need that money to be accessible to us, but we also don't want it to kind of totally be accessible to us because then that money will be gone, right? So we have to think about what is the best vector for that information to come to us? What is the safest way for that to come to us? And when we think of this, what is the way that the human gets to it? What is the prime destination for us to access that? So we think of that, we think of translation apps on mobile. So we're talking about the where, right? So if I'm in a place where I need to use a translation app, then that has to suit that different instance. So if I have a specified translation app for only one language, or if I've only downloaded one module for using Translator in some environment, I've actually, as the human being, shifted my where for that prime destination. The when, right? Prime context. So by this is using context. This is like what my Weaver Labs messaging app did, or that's what that car example did, is that it's your smart home, knowing where you are in the house. That information has that context about where you are, and it's to be able to use that information to come closer to you as a human being. That little Aibo has some sensor here, right? And it's able to walk up to you and know where you are without running into you or falling off the steps or something like that. That's information coming in and using context inside of your world, right? Knowing the when as well. And then the prime interval. The prime interval example that I can give you is perfect with voice assistants. So how many people here have a voice assistant? We've been talking for a long time about voice assistants. In the back, you've got one, you've got it. So a wake word, all of these rely on a wake word. You say, Alexa, blah, 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 blah. But you can't say, Alexa, I want a ham sandwich, and Alexa, set a timer. because it's still processing your ham sandwich request before you're able to make the new request for the timer, right? And that's an accommodation you have to make for the interval in which that voice assistant is going to process your request. Prime utility. This is how much. So the idea of, what is that data? How is that data being presented? And is it coming as frictionless as possible into your environment? And then the prime agency, how are you getting to that? And is it really suiting, suiting the user and how they interact with that information, specifically based on the context of that user? So for example, how many of you have been asked to program your parents' VCR? They invite you over and they say, hey, I can't use this remote for the TV. And you're young, you understand technology, you're all developers. Can you show me how to do this? It's broken, right? Well, you, as a human parent, have to accommodate for that interface to come into it. So maybe that controller can be made for parents. Or maybe you can mix and match different points, or you can come and be like, listen, Mom, I'll put these buttons in. These are the ones that you use. This interface will now better work for the utility of working your VCR or using your TV. So what I want you to think about, the big takeaway of this is, think of your user's proximity to information, the way you think of design patterns, and seek out the prime interface. And talking about earlier what Marcus was saying during the first keynote about how there's this kind of crazy distinction between creatives and developers, right? That's nonsense, right? Ragnar was saying as well, like, what is your responsibility? Maybe my responsibility as an engineer is just to code, and I don't have to think too much. No, it is your responsibility to think about design. It is your responsibility to think about what design patterns to use in the right scenario. That list I gave you about the 3 different types of design patterns, you should know what to use and when to use it. So please be thinking about that and code intelligently. And I'm open for questions. If there are any questions, think about it. If you want to ask me questions later, you can connect with me on Twitter, and you can also send questions using that hashtag. Please do. And I will make this deck available to you on my Twitter. So follow me, and you'll be able to get it. All right? Any questions?
AI, IoT, and robotics are the good side we do using the data we give every day. So what will be the bad side of it? Let's say what happens, what Elon Musk said about the AI and robotics. So
Right.
my question is, don't we need any regulation system to how we use this data?
Right. Well, I think one of the fears with AI, one of these kind of imaginary fears with it, is the idea that if there is a computerized consciousness, it can cycle itself up to operate faster than we can as human beings. So one possible answer for how we can combat that as human beings is to create a more frictionless interface to data. That's one of the motivations for Neuralink. But of course, the ultimate end game of that is to have a digitized consciousness, and then you've kind of Kafkaesque created your own digital consciousness, and it's human-like and very aggressive, and the problem, you just created it when you're trying to solve it. Does that answer your question? If you give, so artificial neural networks are designed to mimic the human brain, right? But how many people here have made a neural network? Whenever you're making a neural network, you're training it. You train it with data. So if you're using it for a specific utility like computer vision, right? You're saying, okay, well, this neural network is going to understand stop signs. So what you do is you take all of this data about stop signs and you pump it into the system so that when it's driving down the road, ha, that's a stop sign, all right? One of the concerns about a digitized neural, like a digitized consciousness, the singularity, right, if that derives from a search-centered neural network, artificial neural network, is that we may not have control with what we train it with. And I don't know if you guys have been on the internet lately, but it's pretty aggressive and mean, and there's like a lot of trolls who just tease people, and they're really crazy like that, right? And actually, people have created Twitter accounts that use a neural network, and they bring in data, just an aggregate of all the sort of tweets that people are making. And I think that it was like a racist and a Nazi and like all of this crazy stuff. And you know what? We as human beings, artificial neural networks, we're all a product of our experiences, right? We are being trained. You are being trained by me right now. I am inputting information into you, and you are assimilating that whether you like it or not. You better plug up your ears and eyes, right? Because that's who you are. We as human beings are just an aggregate of what we've heard. And then that talks about free will and choice, and that's even real and sort of stuff. Anyway, I digress. Toys. So I make smart toys. A lot of people, that DropMix product that I showed earlier with the cards that you put down on the table, that's actually meant for adults. That's like 21 and older sort of people. You can take that to a bar and play it if you'd like. But toys, I mean, a lot of people refer to their car as their toy, you know? Or I go to so many conferences and I try on all of this digital optics, these AR optics, right? Like DAQRI or HoloLens. There's an image from, I think, last year's where somebody's using the HoloLens and doing gestures like this, right? I gotta tell you, a HoloLens, all that stuff, that's a toy. This is just semantics. The reason why I work at Hasbro instead of Lockheed Martin or Microsoft or Amazon, which are all fantastic companies, is because I think that there's a great opportunity with the Internet of Things and with sensors and with hardware becoming cheaper and cheaper, that a company like mine that makes products that aren't just technologically engaging, but fun and motivational, and that young kids want to get into technology, similar technologies from Microsoft HoloLens, that's what makes technology real. That might be what actually causes all of this digital revolution that we all urgently want. Because everybody in this room, and this is something that I suffer from as well, is that we're early adopters. We're all technologists. I'm sorry to say, we don't represent the normal populace of people. But when you make mass market products at a reasonable cost, you can actually take those same technologies like neural networks or like expert systems, which is what DropMix is, and you can put that technology in the hands of people around the world. And that's why the brands that I work with now are all ones that even you in Sri Lanka know about. That's power. That's really powerful. That's my toy spiel. All right. Thank you very much.